Easy 'cause you're beautiful.
All right, welcome everybody. Thanks for coming out for the 4th study group, the Udacity training group. Everyone on the live stream, welcome back.
Thanks for coming.
Sorry for having to change the live stream URL on you. We made a last minute error and killed the old URL, so I'm sorry about that. So we're about, after this session, we're about halfway, and there's a lot of great feedback we've had. We had lots of great questions. We've been really enjoying it. With me I have Colt McCandless.
Hello.
From Google. Sean Bennett from
Howdy.
Udacity. And I'm Peter Lubbers. So today we wanted to kick it off with a couple of little details about some of the code, the items you may need to be more aware of. So Colt's going to talk a little bit about some of those the fine details of input handling.
Which is very odd, right? Me talking a little bit.
Just a little bit. Yeah. We're going to try and shut Colt off.
Like 10 minutes.
That's my goal.
Then we have questions from you, and then we have all the questions on the moderator. Now, a couple of quick notes for the people that are here in San Francisco. If you could only do us one favor and take your plates at the end and put them in the bus station, that would be very much appreciated.
And the bus station is around the corner.
That's right. It's now no longer in the room, but around the corner. And the other thing, just a quick round of applause for Google for hosting this event and the great food.
Seriously.
That chicken pot pie was awesome.
Yeah.
It's getting better every week, right?
Chicken pot pie?
Yeah, chicken pot
I
pie.
want to live here.
Right?
Great. So let's get off. Colt, do you want to talk a little bit?
I think Sean's first.
Yeah.
Sean,
Let's start with Sean.
Okay.
So,
Great.
Does mine work? Kind of. Can you guys hear me in the back? Okay, let me just take yours just in case. Okay, can you guys hear me in the back now? Yes. Okay, cool. So I just wanted to start off. It sounds like a lot of you are having issues with the input unit code. I'm not sure why, but some of you seem to be getting cached versions of the code from before it was released. I have no idea why that's happening. I'm still trying to work that out. If you reset your code, then most of those issues should be working. I don't know why you were getting cached versions of that, but we're going to try and sort that out. So sorry about that. And I think Colt was next.
My turn. Fantastic. Quick show of hands in the room. How many of you have watched the input unit so far? The rest of you are bad study group participants. Okay. Should we do? Can you guys hear me if I talk like this in the back? No. Okay. Yeah. Let me turn off this loud.
You have it on, huh?
Yeah. Okay. So, that's off. Testing. Okay, there we go. Okay. So what we need is more microphones, apparently.
Yeah, clearly.
That's the thing. So I wanted to give a little bit of context. So in the class, there's one of the video units, we actually talk about the reason that you don't want to actually handle the computation from an input callback in the input handler. And there's a little description I talk about in there about getting your frames out of sync, because JavaScript is actually an async language, right? So your input handler callback can occur sometime, anytime. You really have no control or any idea when it actually comes to you, right? So you could be actually in the middle of processing some frame and get a callback, and now all the data that you had computed is different because your input data is different. So that was one of the reasons. I actually wanted to point out something else, which is actually more along the lines of performance than it is of sort of causality or anything like this. So anyone in here interested in writing fast web applications? Right, performance matters, perf matters. If any of you guys actually follow me on Twitter, we're actually starting to use the perf matters hashtag. And so if you start seeing that come up more and more and more, we're really focused on making sure people write performant websites. So I actually wanted to show this diagram today because there's another reason, and probably a little bit more important reason, that you should not handle the code computation for an input callback inside the handler. Basically what you should be doing is just caching those results and then actually handling it later inside of your request animation frame. So what I want to do is really quick walk you through how Chrome works internally, because I think it'll actually help you understand why this is such a bad thing. So first off, it's important to know that the processing thread for Chrome that handles JavaScript is not like a while loop that's just sitting there at the start of your program, right? There's not actually like a tight little loop so things are executed in a very specific order. Rather, hopefully you can see a little bit up in the top corner here. Let me get the right drawing primitive. So rather, it's actually just a while loop that's just going to sit there waiting on an event loop, popping messages off this event loop and then responding to them. So basically this is event-driven processing. Many subsystems are all communicating with Chrome. They're sending message packets back and forth. Threads will pick these up, process them, and then move on. So this really means that if a thread sends 2 commands to the main thread that JavaScript is processing on, they could come in different orders. They could come in at different times. They could come in 16 milliseconds apart. One of them can cause a GC, et cetera, et cetera, et cetera. So you need to have this mental model that it's not a while loop, that code is actually executed in a linear fashion every frame. Like it doesn't do input, then network, then render, input, network, render. That's not how it works. So hopefully you can see this in a little bit in the diagram. So in the middle here we have the event queue, right? So let's just hypothetically say that that's a good drawing of an event queue. I don't know the proper UML, schema, DNA, mumbo jumbo that goes with drawing this correctly. But anyhow, so you can see the event queue will actually get some commands back from Chrome. Chrome may say, hey, I need you to go pull the camera or the audio processing thread or something like that. And so those will actually kick out to the Chrome miss category. We could also be getting network processes, right? Actually doing TCP, UDP, WebSocket requests, HTTP requests, REST, any of that stuff. Those things will all come back and forth through the event queue as well. The interesting part that everyone in here should be focusing on is actually the callbacks into V8. So this is where that main thread is actually calling code inside of JavaScript. For those of you who don't know, V8 is actually the code name of our internal JavaScript virtual machine. Right? So anytime I say V8, that's the actual C++ code that runs JavaScript. And I've said this before to much the chagrin of many JavaScript developers. But you know, a browser is not a magical unicorn paradise. It's actually C++ code that's been highly optimized to run all of your magical unicorn JavaScript. Right? And so you need to keep this mental model in mind, is that it's not JavaScript all the way down, it's JavaScript, and then you've got all of this C++ that's making it fast. So the callbacks from the main C++ into JavaScript. So for example, if you do a post message, right? If you're actually communicating between frames or elements on a page, input handling, callback, stuff like that. Image onload, as we've already been loading images, that's actually a callback that'll come into V8. Set interval, actually, too. So set interval is an interesting process because you'll actually say, call this block of code some milliseconds in the future. Actually, you're not guaranteed to get it exactly back at the interval you set, right? And the reason for that, hopefully we'll talk about in a bit. So you'll also see these 2 little notes here, GC target and restyle target. What you should be aware of is that anytime your JavaScript is executing, you can actually fall into a garbage collection pass. There's really nothing you can do about it, right? So JavaScript will decide, hey, we need to do a garbage collection phase, and it'll go off and do it. So pretty much anytime, even when you're just handling your input callback, all of a sudden you may lose, hopefully only a half a millisecond or something, but hypothetically you could lose 16 milliseconds to the garbage collector running off and doing something. The same thing with restyle target. Anyone familiar with reflows? Browser reflows? Okay, so I'll cover this really quick. Anytime you write a property to the DOM, so you're saying like this DOM element dot position equals XYZ or something like that, you can't read from the DOM again until every element in that page has been recomputed. Every position of every element has to be recomputed before you can read it again. So if you do a write and then a read, you're going to have to wait 3 milliseconds for all those things to be recomputed. And then if you do a write and a read, you just lost another 3 milliseconds. And then a write and a read, now you've just lost 9 milliseconds because you're not properly doing the order. So when I say restyle target, what I'm actually meaning is that your code and your execution can actually cause these reflows to be occurring at odd rates, and you're going to be actually losing processing time because the DOM's being recalculated. Okay? So this has little and less to do with JavaScript games that use Canvas, but it's important to know. Here's the reason why. Down here at the bottom, we've got this nice little block. So anyone familiar with a VBlank? Yes, I love rooms that don't know what VBlank is. Okay, cool. So does anyone know what a monitor refresh rate is? Hopefully everybody. Awesome. Okay, we'll start at the basics. So your monitor will actually refresh at a specific hertz, right? Well, what we call is when the hardware actually receives a callback alerting you that the monitor is refreshing or the video card is doing its thing, we call that a VBlank. Now what happens is Chrome will actually receive a VBlank callback with some magical mumbo jumbo that I won't get in here. When it does, that's when it actually kicks off a call called request animation frame, and you'll actually get a callback in JavaScript. So you can actually respond to the fact that VBlank has occurred. Now this is a little bit different than actually set interval timer. So set interval will say, hey, call this again in 10 milliseconds. Well, what may be happening is that you may have 15 or 30 milliseconds worth of events in the queue before that set interval event gets pushed into the queue. right? So you can say, hey, call me again in 10 milliseconds, but then you've got 30 milliseconds of work, so you're not actually going to get it for 30 milliseconds later. So this can actually be a problem. The same thing actually happens with a request animation frame. Now here's why this matters so much. As soon as your request animation frame, and we'll talk about RAF a little bit more in the physics unit, right? Yeah. So this is a little bit of sort of looking ahead. Once your request animation frame finishes, the immediate next thing that occurs, as soon as the RAF callback is done, is that Chrome will go into its layout, paint, and composite mode. So as soon as your code is finished executing, Chrome says, cool, you're done with your thing, I'm going to go do mine. So if that RAF callback is longer than 16 milliseconds, right, or even 13, 12 milliseconds, you're not going to be hitting 60 frames a second because your entire frame, start of frame to end of frame, has to complete in 16 milliseconds. Otherwise, you're going to miss that next V blank from the GPU process. Okay? So here's another reason then that you shouldn't be handling any of your code for input in the input callback. Because what you want to do is you want to make sure that that event queue is as clear as possible. So when that V blank callback comes up from the GPU thread, you can respond to it immediately with your RAF and actually allow this entire composite down here to go paint, resize, all these other things. I see some people are asleep already. Good. Nap time's awesome. But if there's anyone that wants to talk about questions for this, let's go ahead and talk about those now before we get into some of the stuff on moderator. I know this is a little deep in the bowels, but believe it or not, the understanding of Chrome's architecture at this level is critical for high-performance games and web applications. And by the way, see this entire diagram here? It runs about 3-4x slower when you put it on mobile. Right? So it's even more important that you look at this from a performance standpoint on mobile because, man, if you're losing 3 milliseconds in your input frame, you lose your VBlank, et cetera, et cetera. One other interesting thing, too. So VBlank will trigger off at the refresh rate, so 60 hertz, right, every 16.6 milliseconds. Now, if you end up in a situation that you miss your VBlank cycle, you may actually miss 2 frames as a result. So let's say VBlank occurs, but we actually don't respond to the VBlank until 5 milliseconds after it, right? So now we only have 11 milliseconds to process all of our data so that we can hit the next frame. But you actually compute 15 milliseconds, so now you miss that next VBlank, and you actually have to wait 16 milliseconds for the next VBlank pulse to come around. So you've actually just missed 3 frames because one of them went long and you started Brian. So this is a very, very important concept that everyone in here should understand is don't do things outside of RAF if you can. Try to do as much processing inside of that RAF callback. Consider that your update loop. Consider that the source of all truth. If you get any callbacks, just cache that data, push it into a queue, and then inside of your RAF, respond to it in your own time. This is super critical for high-performant code. That's my rant. Question here. Please use the microphone if you don't mind. It's just right here. Sorry, you kind of got to do the walk and talk thing.
When you talk about this, we bring how much is Chrome specific or how much is cross about the browsers?
Very good question.
That's a great question.
Yeah.
So the question for the people at home is that how much of the time is actually Chrome specific? So basically, if you have 16 milliseconds to hit your frame, how much is Chrome taxing you, right? The problem is that actually varies per frame. Sometimes you may be getting different callbacks or sync notifications. As a general rule, I personally say that you get about 12 milliseconds. So just cut 4 milliseconds off in terms of tax. And this changes, by the way. Chrome rolls out every 6 weeks, right? If we're lucky. It rolls out every 6 weeks, and every 6 weeks performance changes, things changes, so definitely profile your code and make your decisions there. But I generally expect we only get about 12 milliseconds. Now this brings up a new interesting question, unfortunately, that the browser world will get many angry tweets from me about. What happens if you can't hit 16 milliseconds per frame, right? Like if your overhead is just at 20 milliseconds. Well, in that case, in that scenario, you're going to have to try to lock yourself somehow at actually rendering at 30 milliseconds, because that's the next interval down that the human retina will actually respond to proper animation frames without jerking. Anyhow, long thing down there. There's a separate tweet archive for that. But another question.
Okay. Well, actually, this is a little bit higher level question.
Okay.
I mean, we all love Chrome, obviously.
Yes. I like your style. Awesome shirt, by the way.
Oh,
Original
the
Chrome box. Yeah. For those of you who are at home, you can't see this, but the original Chromebooks. They shipped in a box that had this a hand drawing of a hamster. Actually, is there any way you can come around?
Yeah. Come around.
Without breaking everything.
Come back around.
Let's see.
Please,
Yeah, come on
please
up
don't
here.
trip
Big
and kill
hand for him.
yourself.
Big hand, everybody. Big hand for this guy.
Yeah.
See if you can see it. The original Chromebooks, because we were trying to do something super cool, we actually had this hamster and then this diagram of like a hamster wheel powered jet rocket of death. right? It was all like torn apart, and it was like thing A goes in slot B, and this little hamster's like got a helmet on, like, oh yeah, I'm going to the moon, man. Sorry, he's wearing the shirt.
No, it was a great story. But yeah, I was just wondering, I mean, besides Chrome and WebKit, does the same process apply to other, unnamed browsers?
Great question. So this, what you're seeing here is actually in most WebKit implementations. The question was, besides Chrome and WebKit, what other browsers exhibit this? Again, every browser is going to have their own way that they handle composite, reflow, and repaint operations. I think it's a great question. Anything in WebKit is going to follow this similar pattern. So I think one of the big browsers actually just announced that they were moving over to WebKit. So you can expect to see this flow out pattern through their stuff as well. Besides that, I have no ability to comment beyond the scope of the length of my hair.
One thing we do have control over in JavaScript, or at least we thought we had full control over, was set interval. We're going to have a calendar game. It's going to have a calendar in it, so we're going to have a set interval there somewhere. So you implied that if you have a very low interval, you're not guaranteed to get your interval event at that location. But if you have grosser intervals than that, does Chrome actually then give you, say you had a second interval, will you always pretty much be guaranteed to get it on a second, or does some extra processing actually push everything off?
Yeah, great question. So the question is about set interval. If you have very coarse intervals set, are you guaranteed to actually get your set interval callback close to there? And what I'm going to say is that don't trust anything with set interval, because again, what happens is set interval is going to have an event that gets pushed back into this event queue. And whenever that event queue gets around to processing that event, that's when you're going to get the callback. So you could have a 16-second callback time on set interval, but let's just say that your RAF block down here runs at about 48 milliseconds total each time. And so you've just got a bunch of these cataloging, and so you may get your callback and then have to wait 48 milliseconds until you actually get the ability to process the set interval. So my suggestion to you would actually be add a window.performance.now to the actually, I'm sorry, RAF actually gets a callback, right? RAF actually gets a high performance timer callback. So you can actually, again, we're getting ahead of ourselves here. I apologize this for everyone in the room. So request animation frame as a parameter will receive a timer value, a timestamp, which represents when it's called, or the delta from the last frame.
I'm not exactly sure, but
yeah, well, I thought it was the delta, but I could be wrong.
It might be the delta. Yeah. So, but basically, you can use that value and query it against the last time you received that hash tick mark to figure out what your delta is. So you can actually find out if you ran in a second or a second and 12 milliseconds, and then adjust all of your animation accordingly. In fact, just as a quick side story, this is how modern modern games of all size, RTS, FPSs, and everything, actually adjust their animation layer to hide latency. So effectively what they'll do is they'll get packets back. This thing keeps cutting out. I think it's my personality. Basically, they'll get packets back from the networking layer, and they'll get packets back from the networking layer, and the animation system will actually take into it a variable value that represents how long it's been since you've ran your animation frame since last time. Okay, that's dead. So the value means, effectively, they'll take this value, and then they'll use it to actually interpolate the animation of the character. So if you notice when you're playing an RTS game, sometimes the character will like hop in position because of low network latency. This is taking into account that animation value and noting that the position that you're going to can't be smoothly interpolated to. So as a result, what they'll actually do is just hop you to the next position. Now, good and awesome developers will take this into account and actually try to put some more client-side prediction or linear smoothing in their code. So instead of actually like hopping, you'll just see the entire simulation slow down, and that'll hide the latency in a different bandwidth. I want to get to your question, but I want to give Tony his time because he's been standing up here. Sorry.
Yeah, this was just a follow-up. So say I do have a gross interval like that, and somebody in the event system, not necessarily me, okay, does something that pushes it off. So I get my 1 second interval at 1.2 seconds, say. Will I get my next second interval at 2.2, or does Chrome refresh that?
I think that's a great question. Yeah, so Chrome is going to, under the hood, try to match whatever the set interval you ask for. So if you've asked for 10 milliseconds and you didn't get your last one until 8 milliseconds over the time, in 2 milliseconds it'll push another event into the queue, right? Because it's going to try to give you back as much as it can. Question, sir?
The algorithm.
Can you come up,
yeah.
Mike?
Sorry. By the way, we put these chairs here because like 6 people almost died last week. So thank you for not moving the chairs.
You mentioned the processing, the faster speed, the speed, performance. Where are the algorithm? Are there any particular packets or libraries that we can use as reference points for algorithms?
Oh yeah, that's a great question. So the question was about, we talk about client-side prediction and we talk about linear interpolation and things like that. Is there any libraries? Unfortunately, not in JavaScript. Most of the time, the actual de facto that I point people to is actually the Steam source code. So if you actually go look at the Half-Life 2 source engine and type into it client-side prediction, you'll actually get an amazingly detailed write-up where they talk about modifying your update and animation and position based upon your network latency and what you're getting. Because those guys are actually using an authoritative server. So the server will actually say where all of the units are in the world and actually pass that data in a lazy manner down to the clients. And then the clients do some prediction and everyone syncs up. And we'll talk about this quite a bit in the next GRITS course where we actually talk about client and server and how this all works. So in the GRITS code, we actually have an algorithm for this predictive smoothing. It's gnarly, but if you email me, I can show you where it's at and take a look at it from there.
Okay.
Any other questions on this topic? It's a fun diagram. I have it tattooed on my body somewhere. Winner gets a T-shirt.
Everyone gets a T-shirt. They're out in the hallway. All right, so let's take a look at the questions. All right, so the first question was about the recording of Unit 3. So we haven't been very successful with our mobile studio. So last week's recording, everything went fine, but it's still, quote unquote, processing on YouTube. We actually have a call in to get that fixed. Expect that to be fixed either tomorrow or the day after. If that is still not fixed, we have a complete copy and we'll post it. The only problem with that would be that it would be a new URL, so all of the links will be broken. So we're trying to get it fixed in place. Stay tuned for that.
Yeah, the YouTube team knows all about it, so.
That's right. Good. Okay. Let's see.
Okay. I can probably take this one. Is my
You're pretty good.
My mic is actually working okay, right? Okay, good. So this question is, Andy made liberal use of the instructor notes section during Sebastian's and Peter's courses to clarify, correct the videos and quizzes. Although we're working through these in the forums, it would be great to acknowledge them in the notes. Yes, excellent, absolutely excellent. I love this. I would love to add in more of this stuff in the instructor notes. Actually, one of my pipe dreams, I guess, that I've been pushing for a while is actually to turn all of that, basically all of the information about the course, the instructor notes, the supplied code, the grading scripts, all of that, basically into its own GitHub repo, so that then people, if they have useful content to add, could just issue a pull request, for example, to the course, and then say, hey, I've added this animation or I've added this, diagram for this topic. I think it would really help. Or, hey, there's this problem with the grading script or with the supplied code. I've pushed the fix. This is something I've been pushing for a while. I think it might actually be happening now, but it's going to take a little bit before that happens. It's a bit of a side note, but yes, absolutely, we should definitely do a better job. If anyone has specific diagrams, specific notes that they would like to attach to the quizzes or any specific quiz, please email them to me. One of the problems is that searching our forums, if you haven't noticed, are somewhat difficult to search through. So searching through them for some of these gems is kind of difficult. If you have suggestions or anything that you would like put up in the instructor notes, please email them to me. That's by far the easiest way to get a hold of me.
Yeah. Great, thanks, Sean. Okay, so next question, maybe a good one for Colt. What's the best way, in your opinion, to give the user the option to remap his controls?
Fantastic. So testing? No? Good? Not? Okay.
Take this. We're back.
This is that mic's officially dead. So this is a great time because anytime there's a question that says "in your opinion," I officially have to say that my opinion is my own and not that of any representative bodies I may be associated in any way, shape, or form. Anything you do with the data I provide is of your own accord, and we cannot be held accountable in any way. I got that memorized now.
Yeah, you're good at
I've been
that.
through enough PR training.
Yeah.
So,
So it's really you.
It's really me. Yeah. So my high suggestion here is that you actually create a UI mode where, so basic standard Quake 1 style stuff, or Quake 3 I think was probably the earliest example of a really good way to do this. You provide a UI to the user, allow them to see the actions that your game is performing. The user selects an action either through click or spacebar or hit the button that it's currently bound to, and then in your UI you can actually put a new key listener in that says, hey, let's figure out what the user hits next. So if the user clicks on fire and then he hits the Q key, now you actually go in and change that fire key to Q. Now, there's one of the important things about the GRIT's input system was it was built to focus on this since day one. So typically in an input system, you've got some if statement buried deep in the bowels of your code that says if the user hit the letter Q. Right? And we actually think this is the wrong way to do it in game development. Early on, if you notice in our init functions, I think it's in game engine. Init, right?
Yes.
Client-side game engine.
No. Input engine.
Input engine.
Yeah.
We'll actually say, map the key to Q to this action, right? Move forward or shoot or jump or something like that. And then later on in the code, we can actually just call a single function that says now map A to shoot, now map J to shoot. And then the rest of the code actually doesn't have to be changed because those all query off of whether or not that action has a Boolean state on or off or has been executed. Mm-hmm. So with the current GRIT setup, it actually maps itself really well to providing this sort of experience. We didn't do it because we're lazy. I hope everyone in here who's building a product is less lazy than I am. That's my heart. That's my heart goal.
Great. Thanks for that opinion. All right. Sean, I think this one is for you. Okay. I was able to pass test cases for quizzes on input handling, but is there something I or Sean could do to allow testing on the canvas how my code handles input? This is from, I've been forgetting to
Karnak
in San Diego.
Yeah,
it's a cool name.
Love
that
San Diego.
An interesting question. To test it while you're moving around on the canvas in the game world, is what I'm presuming Karnak's asking. And my best bet would actually be we would have to put in some kind of logging framework that they would have to call out to during their event handlers, or when this input actually occurs in their code.
We would have to take control of the event handler.
Yeah, we would have to take control of the event handlers.
And they would implement a function we call.
Yeah, that's really the best way I can think of to do that, which I don't think is really the right way to go about it. Unless you guys have other ideas, but I don't think there's a better way to do that. It would be really cool, but I don't think if you weren't in control of the code or writing code, then that would be a problem.
Yeah, testing on the canvas.
Yeah. Right. Something to think about, but that's my best bet now.
The only other thing I can think of is Chrome developer tools, and all developer tools have these ways to pause on any sort of input. Like you can say, okay, I want to stop on anytime you hit the mouse click or mouse up or whatever. And then you can immediately jump to the part of the code where that's happening. I don't know if that's...
That wouldn't be grading though, but that's something he could do. So the first part of that question, I think that fits.
So could we put a canvas on the quiz page?
There's a canvas, but there's no way to grab grading input from that directly.
So it's
since
it's
just
is it an iframe?
Yeah, it's in an iframe.
Okay.
Yeah, I would say the developer tools are really your best bet there.
All right, so another question, guys. Lots of awesomeness, let down by a buggy test, lack of explanation of the concepts. Comes back to what you said about believe it teach a man to fish and he'll never be hungry. Right now it looks like we're wading through the GRIT's code base.
I think I stopped listening after you said awesomeness.
Well, I mean, if you have some specific feedback, I mean, yeah, we would love to fix it. We're listing things to improve and make better. It's a matter of getting to all of them, but you've got to give us specific feedback.
Email Sean.
Yep, email me.
Give Sean a hard time. Well, just to give you some credit, I mean, there's been, we had some definite issues in the beginning, but it has gotten a lot better.
Yeah.
So, but yeah, if you find any issues, there are certainly more out there. Let us know. Also, if there's questions from the audience here, just feel free to come up to the mic and
yeah,
go for it.
We should get a back of the room mic.
Yeah, we should get a
that's
back
right.
mic.
Sorry.
Just related to the test code, is there somewhere where it's accessible? Because I know one of the things I've run across is, like, for example, you're defining a variable that I defined and I didn't know you'd already defined it in the test case.
Ooh, okay.
So, how can we see those kind of things? I think that's the problem. That's probably what's being
Right,
alluded
yeah.
to here.
That's one thing that I would like to put up on the instructor notes, so I will put that up either there or on the wiki, I think would probably be the place to put it. So,
Excellent.
yep.
Yeah, that's a great question. Because basically the question was, can we have the grading code and the code that's actually running available? And there's nothing really there that's causing us to hang on to it, right?
Yeah,
So-
no. And that, again, I would like to make all of that available and accessible and changeable. I would love to have all of that info on GitHub so that you guys could all access it and see what we're doing and how we're doing it, and suggest better ways to do it if you guys have ideas, because I'm sure you do.
Okay. Getting a lot of static here.
Yeah, there's a lot of static.
Okay.
Is that mine? Okay.
Last week you said the genesis of this course was really as a vehicle to highlight HTML5, in particular the canvas. And so learned a lot in the Atlas section and the mapping, and then talked about user input. So this is just a question that says, if I have a game and I have all these elements on the canvas is really just a rasterized device. How can I hit test on that when I have to literally backtrack through my drawing of atlases and maps in order to hit test it, to have a game with a nature to be able to control different objects on the screen rather than just one element?
Mainroach.blogspot.com. There is an article that talks about fast canvas hit detection. There's actually two of them.
Follow up. If we drew SVG on the canvas, and I know with 3D you can, those actually have automatic hit testing things built into the infrastructure that draws on the canvas. Am I correct in saying that?
I don't know anything about SVG.
Yeah.
But would you use it
I know
on the
3D
canvas?
does. Okay.
So that I think the API he's referring to is the I think it's experimental or something, where effectively you define a shape primitive. So for those of you on the feed, sorry that you can't hear this, he was asking about whether or not the internal SVG processing, which already has some hit detection in it. I think how that works is you actually define a primitive, and then through the SVG API, and then define a point to that primitive, and then get a Boolean result. I think this is, so I haven't done the performance test, but something in my brain back here in the reptile area tells me that's a bad idea. So when I said go visit my blog, I got actually a really wicked look from one of the Udacity community managers over here, like, what you're just going to say that and not explain it? So I'll actually answer your first question. Sorry, don't fire me. So basically, to answer your first question, the naive approach is, of course, end-to-the-end solution, where you actually test the point in 2D against all the 2D rectangles of objects in space. As number of objects increases, this, of course, tanks your performance through the floor. What my article actually talks about is starting there and then making it faster. And there's a couple different ways that I do it. The first one is actually using spatial binning, right? So effectively what I do is I tile up the canvas into 64 by 64 buckets, and then any tile that's rendered into that bucket, I effectively make a reference mark to it. So then when the user clicks, I only walk through the list of other objects that are touching that same square. Now this is fantastic if you're doing basic 2D rectangle-based collision, but if you're actually doing something isometric, like a Farmville clone or something along those regions, this doesn't really work, because you actually need per pixel hit detection. Now, per pixel hit detection in JavaScript is going to just kill your performance, right? Because effectively what you have to do is you actually have to call you have to rasterize the glyph or the sprite into a separate canvas, and then call get user data on that canvas, which then gives you a RGBA packed stream for it. And then you have to effectively figure out what the translation point is inside of this linear array and determine whether or not it's alphaed. There's a separate way to do it, is where you pre-process all of your sprites and actually dump those to disk in a binary array and store that separately, so you don't have to use the separate canvas and the separate call. You just have to walk through these binary arrays, which if you pack properly, hopefully you can use some bit shift operators to improve the speed and latency of that. The methodology that I actually go for, because I think it's probably a lot better, a lot cleaner, and a lot safer, is, and you can find this on my article, it actually links to my GitHub account, where I actually have an algorithm that will compute the concave hull of any sprite. So you can actually pass in an alpha sprite and actually print out a concave polygonal representation of that sprite. You can then save just the edges of that polygonal representation to disk, as integers. And this is going to be a lot less memory than either of the two previous operations. And then the code to determine whether or not a point is in the polygon is a very simple algorithm that you can actually find in the article code base as well. So with this, so basically here's the thing. The test that I propose is actually like 4,000 objects on a canvas. And when you click, a couple things occur. First off, you're only touching like the 5 or 6 that actually occur in this bucket in space. And then after that, you're only actually touching you're not actually touching the pixels, you're only touching the concave volumes of the point against that. So the result is very, very, very fast. So for those of you looking to do lots of point queries, in fact, it actually might be too fast at this point. That's one of the things. Like I've over-optimized it. Like who's going to click that many times to make sure that this is performant in a way that matters? But for anybody interested in that sort of stuff, mainroach.blogspot.com. Leave feedback. No one visits my blog. It really makes me lonely.
That's all your opinion, right?
That's, yeah.
Okay,
my opinion is my representation of myself, and not that of any lawyers or anyone.
All right. So if you have any questions, feel free to jump up here to the mic. We'll take another one from the moderator. How can we accommodate odd keyboard layouts? One common layout is AZERTY across the top, which makes WAS controls bad for games. Needing 2 sets of keyboard directions like grids. Can this be done without making the user fix his controls manually?
Not really. Not in JavaScript, at least.
Yeah.
Now, if you have access to the device drivers, then maybe, but definitely not in JavaScript.
So
So you need some key mapping, and you need a way for the user to actually be able to interact with that and modify it.
Yeah.
So you need a UI for it and everything.
Well, definitely something people are playing around with. In the input unit, we see how to control the mouse and the keyboard. Are there good approaches and docs for controls or for controlling our game using the Android device? From Marino and the Canary Islands. What's your opinion on this?
Fred Sauer, who's a developer advocate for Google App Engine, not only besides being a developer advocate, he's also a gentleman and a connoisseur who worked with us on the original Grits code base. He actually wrote this code, and it's actually part of the Grits code base. So if you go to the code repo for Grits, you'll notice that there's a folder called WASD. This is actually an Android client that will connect to the Node.js backend and communicate with it and pass input data from your Android device to the Node.js instance. And the Node.js instance will take that as gospel for where your player is moving. So for those of you who've actually been able to get into the live instance, when you join a game, you'll notice when you're configuring your little robot, you'll actually get a QR code. And so what happens is you download this app from the Play Store, you scan the QR code, and then you actually just use your device as touch input, and it'll actually move your character around in the world. There's a little bit more lag involved with it because it's kind of doing this weird round trip. And plus, like, you have your device. So basically you hit a key on your Android, it has to go up to the server to then tell your client where you're at. So basically this philosophy actually invalidates all of the client-side prediction code that we had added and put in there to actually make everything look smooth. But the fact is that code is all in our code base, and you can check it out. And if it's too crazy or chaotic, blame me and Fred Sauer and send us emails and whatever other stuff.
There's also that Super Sports game that was recently released for Chrome too that does
Super Sugar Sync or something?
Super Sync Sports.
Super Sync Sports.
Yeah,
that's what it is.
That's really
They do something fairly similar, I think. And
I think it was an API.
yeah, there was an API.
We're actually going to release an article about how it was built.
Yeah,
sometime
it's pretty fascinating
maybe.
if you look at the code.
Yeah. Cool. All right. So is it possible to announce when the testing backend is operational or broken? It would be nice to know whether a problem exists in our code or your code from Steve in the Bay Area. Go for it.
Okay. So again, some of you were getting cached versions from before the unit was released. Not sure why. The other thing is that the emailer that we were using before we changed our site over in late January didn't actually work with the new site. So we were working with kind of a jury-rigged email/announcement system, which made it a little bit difficult to get in touch with all of you. The good news is that we now have, as of, I think, Thursday, a brand new emailer system. If you guys got the email for this study group. It looked quite a bit nicer than the last
Yeah.
one. That is part of this. So we should be able to contact you much more easily about any problems from here on out. So yes, we will definitely do that. Thank you for asking that.
All right, thanks, John. Yeah, those emails look a lot nicer. Thanks.
Hey, thank you.
And that reminds me of something. Just a quick add note here. We're running a contest. I know all of you know that, but for those of you that are just joining the live stream or are new to this session, we're running a contest. The details are on the Udacity wiki page. It's running for about a week or two after this 8-unit course is over, the study group. And there's some cool prizes. So you can win a ticket to Google I/O. You can win a cameo appearance in one of the future Udacity courses. There's a bunch of Chromebooks and Nexus 7s for all the different categories of prizes. So definitely check that out. It's probably, since we're about halfway in the course right now in the study group, it's not too late to start. I mean, how many of you here are thinking of submitting something? Okay. So,
Wow. Okay.
Wow.
Most everyone.
Fantastic.
This is serious.
If any of you have questions about what you're building, this is the time to ask, by the way.
Yeah. If you guys
Or
have
how to build it.
If you have questions or problems in your architecture,
Yeah.
talk about it here.
Yeah, I find those questions
I
fascinating.
just want to ask, can I use Impact.js for that?
Yes.
Yeah.
Right. So the question was if you can use other libraries like Impact.js, and that's perfectly fine.
Yeah. Really, anything that compiles down to JavaScript is good.
Right.
So
Yeah.
if you want to use Dart, for instance, or some other language that compiles down to.
And also, mad props shout out to the guy who made Bombermine. I don't know if you guys have seen this. What was the
this?
exact URL? Bombermine.ru.
What is this? I don't think I've heard of
It's
this.
like a massive multiplayer Bomberman clone.
What?
He's actually one of our students.
Seriously?
Yeah, he actually sent me an email. So if you're on the video feed, mad props. He's actually one of our students and taking our
Yeah,
class
nice.
and shipped Bomberman.ru. It's
right.
a massive multiplayer Bomberman clone. And I played for about 5 minutes and died like 800 times. So obviously my Bomberman skills are not what they used to be when I was 5.
One other thing about the contest, I'm pretty sure we announced this last week, but just in case, we've extended the deadline to April 8th, I want to say.
So you have plenty of time to take the entire study set of
sounds
study
right.
groups and submit afterwards.
Yeah, so it will be after the last unit is launched and everything, because that didn't make a whole lot of sense.
Yeah, for those of you that are on the live stream, you didn't see how many hands went up. Probably a good 20,000. What do you think?
20,000 people? I think
About-
20,000
Yeah, there are about
submitted.
20,000 people in the room that are all.
Can we get
part
that
of this
confirmed by the
contest.
Udacity community managers?
Yeah,
20,000?
Yeah, there was a
20,000?
nod there. Yeah.
Yes,
okay,
we're getting the nod.
Yeah, that wasn't a lie at all.
AT&T Park after all. Right. All right. So back to the questions. Oh, wait.
Wait,
This
this
one.
one,
So hi there. Thanks for the great course. It's possible to list the programs, games, sites, and recommended tools you mentioned quickly in the video somewhere, in the wiki page or somewhere else. So it's hard to write it all down quickly. From the Canary Islands in Spain. Awesome.
Okay, yeah. Yeah,
So-
we can definitely do that.
We can
talk about that afterwards and figure out what we need to list and what's cool and what's not. And
Yeah, the good thing is we have a lot of our original storyboards that mention all these things, so it would be pretty easy for us to go through there. And then also anyone can add things to that, right? So
yeah, if anyone
actually,
has suggestions for cool tools to use, like Impact.js, please add it to the wiki.
you want to give a plug for it, Iverlet?
I'll provide a tool.
Okay, there are tools. All right, so grids is complex. I feel it's overwhelming for the time we have in CS255 to achieve everything you've done. Frameworks, Create.js can make things easier or not. Without prior HTML5 and JS experience, will we be able to deliver something like grids from Portugal? Well, so first of all, we took the client-side part of grids and turned that into this course, and there's other parts like the server side that we're hoping part 2 will be. So it's not everything you're seeing in the actual grids game. We specifically, and we mentioned this a couple of times over the last few study groups, tried not to go immediately to all the different third-party libraries, just to have a little bit more of a sense of what's really happening, except for like the physics parts where that would just probably just add to the confusion. So, thoughts about that?
I think in order to really understand how to build a performant game or a performant web app, period, you kind of need to understand what's going on at a fairly low level in terms of JavaScript at least, which.
Yeah.
Tell them how long it took to build with how many people. So
So Grits went from concept to Google I/O open source in 120 days with 6 Googlers working in our 20% time. So we were basically working 1 day a week. And about the last month, that actually turned into me working 5 days a week, but don't tell my manager. You generally need to understand how some of these things work. Yes, it is confusing, and that's what's so awesome about it. If you're an engineer, you should have a love of solving problems and looking at things a different way and finding and digging and yearning to know how these blocks work together. Programming is not easy. Generating games is the worst of it because it is not easy, and you have to have a designer and an artist and a business manager. I roll intentional. Love the fact that you're getting this low-level stuff. I actually saw someone sent out a tweet that had a picture in a book. It was a book. It was a scan of a book. I couldn't believe this was in a book. It says, if you would like to make this more performant, you should use something more low-level like jQuery. And my head exploded. It's in a book. Someone wrote that down, and someone else read it and said, yeah, that's good.
That's a good idea.
2 people agreed with that statement. Probably 3.
Technical reviewer.
So yes, Sean is right. If you need to understand how to make something performant, you got to go down and you got to understand, and you don't use jQuery. 3 people.
It was in a book, right?
It was in a book. Someone, All
right, so we have another question from Karthi from Chennai. Hello world, doing maze game in HTML5, find a route to the destination. I'm stuck in the game validation whether the user reached the destination from the starting point.
Okay, yeah.
Help me how to check.
Okay,
I use Canvas to draw the route.
Yeah.
Thanks. Any?
Talk about A-star.
Oh, yeah. A-star. Okay, so what you're actually looking for is a pathfinding algorithm, basically, and the go-to here is called A-star. You look it up on Wikipedia or just Google it. There are all sorts of articles about it. There's code in just about every language you can imagine. It is the go-to pathfinding algorithm that you're going to want to use. There are optimizations and modifications of A-star depending on what you want to do exactly, but for a basic 2D game, especially a maze game or something like that, A-star was built for exactly that. Yep. So use it. It's brilliant, it's clever, it's simple, it's awesome.
And there is a JavaScript.
And
there is a JavaScript
library
implementation.
for it. Yeah.
A-star.js?
Yeah. A-star.js probably, I don't know.
Right. Perfect. All right, thanks, Sean. So have you thought about using Phonegap or some other tool to get HTML5 games on?
Oh yeah.
We've thought about that. So I guess one of the things we mentioned already is we're talking about what's next, right? After this, we're thinking of doing the server-side course, and we're actually already thinking ahead after that to how to turn this onto a great mobile game. So, obviously, Phonegap is a pretty popular approach to just take a game and package it up for mobile. But have you actually experimented with it at all? What are your
okay. So I have an opinion
for Grits.
All the things I said before. Yeah. So Grits, we've intentionally designed Grits to kind of not work in these sort of packaged web view modes. Right. So it would work in Phonegap. You'd have to actually call out to, I think, a different WebSocket API or something along those lines. Like for those of you who don't know how these wrapper tools work, effectively they have some C++ or Objective-C or some runtime that will load your JavaScript and load your Canvas data and then operate on it as though it were a browser. Right. So again, remember, browsers aren't magical unicorn utopias where eBay and all these companies make millions of dollars from just putting fonts on a screen. Pinterest, yay! Yeah. Oh, great joke, real quick. Just to segue. This is my funniest joke about the web. Right. Okay. So a new bar opens in Silicon Valley. 400 people walk into it. No one, or 4 million people walk into it. Nobody buys anything and then walks out, and it's declared a smashing success. Only on the web and only in Silicon Valley.
4 million.
4 million. Yeah. So the point being is that we basically Phonegap is trying to emulate the fact that it's a browser, right? So it's running C++. I know there are some other versions of those wrapper tools that are actually running V8 because V8 is open source, and then they're running Skia, which is also open source. So they're basically running the JavaScript processor and the Canvas rendering processor from Chrome in their package, right? And they're running like kind of a different version of Chrome. So these things work to lesser degree or more degree. Most of the time that you're going to find the problems are the APIs that it provides to get native device access, because you really have to ask yourself a question. If you're writing something in JavaScript and using Canvas and it's not performant, or better yet, let me take a step back. If you're writing something in JavaScript and in Canvas, you're either going to run in a web browser in one of these things. Well, it's not going to be that performant on mobile because you don't have the processing cycle or the GPU hertz to actually make that matter. So then if you want something that's more performant, you probably need to write it native anyway, because otherwise you're not going to get it. And if you're writing it in native, you probably want access to native APIs like messages, notifications, because these are what actually make you money. So then you have to have this serious discussion with yourself in a mirror about, am I actually going to write a web game that's HTML5, or am I going to write a native application, and where's the line? And unfortunately, I think this is one of the largest concepts and constraints. And I hopefully this is the match that actually forces the web to move in a different direction. Personal opinion, not that of any of my employers, anybody associated with me in any way whatsoever, or my wife. I really think the biggest problem right now is the web is butting heads against mobile. And the fact is, there was a time when the web was the place you went for easy access to applications. And look how amazing it was. I just open a browser and I get all this data and I get everything, and how easy and how simple it is and how awesome it is and how responsive it feels, because the desktop browser or the desktop applications felt slow and sluggish and cumbersome. And now we've actually gone the other way. Right, we've gone completely 180, is that native applications on your phone feel snappy and responsive and awesome, and the web feels slow and sluggish. And so we've actually gone the other direction now, is that the web is actually the slower version that people don't want to make for anymore. And so I think this is important for the web to kind of grow up and realize that they've hit this problem. And this kind of comes back to my larger philosophy that I've ranted about for a couple weeks now about the web and the technology stack involved, asking serious questions about whether or not JavaScript can get us there, whether or not our current technology stack can get us to where we need to be, where the web can actually start competing in this environment again where it matters to users.
Yeah.
Because right now, native is eating the lunch of the web, man. I mean, it's like, give me your fruit cup, and the web is like, okay, here.
Yeah.
So,
but part of this is actually building the kinds of web programs that you would build on mobile or native, and saying, okay, where does this fall short?
Yeah,
what
absolutely.
do we need?
Yeah. And that's again one of my rants about the web is even if you write that and it falls short, you don't have the much power to fix it. You got to wait for someone else to fix it. You got to wait for the web community to fix it, for someone to pass a W3 specification so you can get a better primitive on a timer or something along those lines. And I'm not saying that this is doom and gloom. Amazing things happen on the web every day. But if you want to actually compete, you got to play the game. Period.
Mm-hmm.
Yep.
Yeah.
But there's hope.
Episode 4, A New Hope.
Oh man.
All right, so we have a question from the audience.
One thing the web does have going for it is exactly that. You don't need Phonegap for it, and you don't need to hire two teams to develop. Eventually, as you said, there is hope, and it will get fixed, and there will be a way to do performing things.
Hopefully,
Because all the apps are building information silos, and it's going to implode on itself anyway.
That's a really good point, because the other day my son, he was an aspiring DJ, put some songs up on SoundCloud, which actually has a really nice web app.
What's his DJ name?
No. You should plug him.
Yeah, plug him, dude.
It's actually pretty good.
Shout out.
Rocky Lovers.
Yeah.
Go follow him on SoundCloud. So he posted it, and then a few days later already had sort of an alert that found this music, right? I had an alert for the last name set and found it. So had it been sort of like put in some sort of app store, would have never found it, right? So really there is a lot of power, and a lot of these the browsers are not sitting still, right? There's a lot of activity right now, and getting on par with all those, the device access, all of those things are moving faster than most people think. Actually, right?
It's doing that in a way that also gives you that same openness that is really the web's hallmark. Yeah.
Yep.
So we've got our final question of the week by the same.
Hi, Dad. Hey, buddy. How you doing? Did you get that thing I sent you?
The dad said from Las Vegas. Last week's Grits game was working fine. Today it wasn't. Does Google need to buy larger servers?
Yes. 16 million people are playing Grits right now. That's the problem you're having. End of discussion. I filed some tickets. Some stuff got fixed, and then it got broken. My fault. I will get on it as soon as I'm done doing all the other things that you asked me to do in your other emails. Thanks, Dad.
All right, and thanks for your support.
Yeah.
So, all right. So, are there any other questions here in the audience? Any not necessarily related to this unit? Any other things that are?
Yeah. Any other questions about your products, the games you're making? Any tricky items that you would like us to rant about?
Yeah.
Well, me to rant, them to sit there and look pretty.
Yeah.
Opinions.
That's what we do.
Opinions.
Can you come
Mike,
up?
yeah, sorry, Mike.
You got to come to the mic.
Some of us didn't get a chance to go to the Google Dart that was here a week or so ago.
The what?
Google Dart about the
Oh,
browser.
Dart for breakfast. Yeah.
Oh, that was fantastic.
Right.
Yeah.
So was there anything that could be used from that event to correlate with gaming physics engines or something?
Yeah, so the question was, there was an event we had here in the San Francisco HTML5 user group like 2 weeks ago.
Yeah, it was 2 weeks ago, I think, on Saturday morning.
Dart for breakfast. All of the materials of that code lab, if you will, are available online. Dartlang.org has links to it. Can you use it for this course? Actually, one of the students in this class, who's not here today, I think, is using that sort of knowledge to build the game for the contest.
And there's actually, I received like 4 different emails from people as soon as Dart for breakfast was over saying, hey, do you mind if we port Grits to Dart? And I'm like, sure, you and the other 800 emails that I've received since Google I/O last year, more power to everybody.
Yeah.
So people are looking. I don't know the status of the project. I think Don Olmstein is heading this one up or something.
I thought so.
Yeah, something like that. But yeah, the Dart's awesome. You should definitely check out Dart.
Yeah.
I'm a big fan of Dart. I'm a big fan of more structured web languages.
Static typing.
Yes, thank you.
Tree shaking.
Yeah.
Tree shaking.
Right.
It's like the Harlem Shake, but for syntax.
Coming soon, right?
Yeah.
Nice.
Make sure you point out the Udacity folks before.
Yeah.
Okay.
So, so with that, I think we're going to wrap it up. A couple of final announcements. So tune in next week for another study group.
Entity unit.
Same time,
yeah.
same place. We will make the live stream URLs and moderator URLs available pretty soon. There are a couple of folks here from Udacity who would like to ask you a couple of questions. So they're waving right now, and talk to them afterwards. Give them some feedback. Don't forget the contest. There's still time. We're about halfway right now, so there's a good 4 or 5 weeks left for entering. And with that, I think any other announcements?
Next unit should be up when I get home to post it.
Right. And I'm taking him home. So.
Yeah.
Thank you all for your time this week. We
again.
appreciate it. Thank you.
Thank you.